Hi, I'm Takhya Holley, an undergraduate student here at UTA studying biochemistry. I'm currently working as an undergraduate researcher in Dr. Peter Kroll's group. I have been working on producing and characterizing chemically etched and non-etched carbon microspheres. Carbon microspheres are carbon materials synthesized via hydrothermal carbonization. Carbon microspheres are easily prepared in a one-step process under mild temperatures and pressures using a variety of saccharide precursors. They are often used in controlled drug delivery systems, optics, and electronics due to their tailorable properties. The aim of this project is to first produce and determine the morphology of the carbon microspheres, then study the effects that etching with sodium hydroxide will have on the surface chemistry and thermal stability of the material. These microspheres will then be used as templates for further coating with a siloxane in the future. We also took a look at how pyrolysis at various temperatures affect the structure of the etched materials. The microspheres were prepared using glucose and water heated to 180 degrees Celsius for 10 hours. The slurry was washed with water and ethanol and filtered under vacuum. The resulting product was left to dry in a desiccator. Chemical etching was done using the dry carbon microspheres and 1 molar sodium hydroxide reflux for 2 hours at 70 degrees Celsius. The material was washed using centrifugation and water until a neutral pH was obtained, then dry overnight using a vacuum dryer. We then decided to pyrolyze edge samples using a heating program of 20 degrees Celsius to 500, 700, and 900 degrees Celsius at a heating rate of 5 degrees per minute. We use FTIR to determine the surface chemistry of the materials, where for both materials, OH, CH, CO double bond, and CC double bond functionalities can be seen in both samples, but the intensities of the peaks vary with the samples. The non-etched labeled CMS have higher intensity peaks for OH, CH, and CO double bond groups. There is also a reduction in the intensity of the CO double bond groups and intensity and an increase in the intensity of the CC double bond groups in the etched materials compared to the non-etched materials. To confirm the morphology and determine the diameter of the microspheres, scanning electron microscopy was done. From the SEM analysis, the microsphere diameters for both materials was determined to be in the range of 0.2 to 0.3 micrometers, but the etched materials showed a more normal distribution than the non-etched materials. The Raman spectra of the non-etched, etched, and pyrolyzed etched samples displayed two peaks at 1350 and 1590 wave numbers, referring to the D mode and G mode of free carbon. The ratio of D to G is about the same for the etched and non-etched materials. The difference appears when the etched materials are pyrolyzed using an inert atmosphere. As the temperature increases, the ratio of D to G indicating the structure of the material is becoming more disordered and there's higher defects present in the materials. To determine the thermal stability of the materials, TGA analysis was conducted from ambient temperature to 800 degrees Celsius using nitrogen. There is an initial mass loss occurring at 100 degrees Celsius, most likely due to moisture loss. There is a major mass loss in the temperature range of 180 to 600 in the non-etched and 220 to about 700 degrees Celsius in the etched materials. A total mass loss of 49% is seen in the non-etched samples and 65% in the etched. The next steps will be to use the carbon microspheres as templates to be coated with polymethyl hydrosiloxane in the presence of a platinum catalyst at room temperature via a dehydrogenation reaction. The impacts of etching will be further explored on the coated materials. To summarize, the spherical morphology of the carbon microspheres was confirmed using SEM. FTIR results showed that the oxygen-containing groups decrease on the surface of the etched materials. The Raman analysis showed as the temperature was increased for the pyrolyzed etched samples, the structure becomes more disordered and has higher defects. And lastly, the TGA results show that non-etched materials are more thermally stable than the etched materials. Thank you for your time.